So we're going to look at some examples from 6.5. 47 is pretty straight forward idea of this binomial distribution. So one thing you want to keep in mind is anytime you're looking at the normal distribution, you have to account for this continuity correction of this 0.5. So looking at the normal distribution, if you're looking for an area between, you're going to have to add 0.5 to the upper bound and subtract 0.5 from the lower bound. So that's something to keep in mind. Very similar to what we did before with the standard normal distribution. One thing to keep in mind is the mean and standard deviation can be calculated relatively quickly, but you have to account for the shift in the upper bound or lower bound or both. So let's look at this first example. We have a normal or a binomial probability distribution of 150 with a probability of 0.6. So we can always calculate the Q. In this case, Q is going to be 0.4. So the average is going to be N times P. In this case, 150 times 0.6, which would give us 90. And then the square root of N times P times Q would give us our standard deviation. Here we're wanting sigma squared. So we take N times P times Q. So 150 times 0.6 times 0.4, which would give us 36. So using the normal approximation, we're looking for the probability x is less than or equal to 67. So we're really looking for the probability that x is less than or equal to 67.5. So we have to add 0.5 since this is an upper bound. And so if we convert z, if you recall, x minus mu over sigma. And in this case, if we plug in 67.5 minus 90 over the square root of 36, we get approximately minus 3.75. And that is not on the normal distribution curve, so it's going to be the smallest amount we can calculate, 0.0001. Find 4 decimal places if we went 68 to 75. The 68 would be a lower bound, so if we subtract, we'd have 67.5. 75 would be an upper bound, so we add 1, 75.5. So this z value we calculated similar to above, 0.0001, or sorry, would be minus 3.75. That's not on the table, so the area is 0.0001. This z value, 75.5 minus 90 divided by the square root of 36, would be minus 2.416. So our table only goes up to 2 decimals, so minus 2.42. So if I go to the standard normal distribution, minus 2.42, I get 0.0078. So I get the area is 0.0078. So if I take this area minus this area, remember the standard normal distribution, this would be the larger area, so I would take this area minus this area, so I get 0.0077. We had number 50, very similar. The key thing to remember is to convert your numbers here to shift it the 0.5 as needed. So we have the probability is 0.16, so Q N is 600. So our mean is going to be 600 times 0.16, which which gives us 96, and our standard deviation, 0.16. 0.16 times 600 times 0.84, which would give us 80.64. So exactly 98. Now remember, we can't do exactly 98. We have to do 98 plus or minus 0.5. So 97.5 less than or equal to x less than or equal to 98.5 in the normal distribution. So z x minus 96 divided by this. So here we get z as 0.018601, which would be looking at 0.02 for z. And then for 98.5, our z is 0.031001, so z would be 0.03. So normal distribution, this is very close to our mean, right? Standard normal distribution. So if I look at 0.02 and 0.03, so on the graph, it's going to give me 0.02, 0.03, right? I'm on this side, so I'm going to take the area for 0.03 and subtract the area for 0.02. So 0.03, 0.02. So I'm taking 0.6179 minus 0.5793. And that gives me an area of 0.0386. Very similar to B at most. So looking at the normal distribution, at most 101. So this is going to be a lower bound. So I need to take 101 minus 0.5. So I'm really looking at most 100.5. So this is the area I want. So I'm actually going to shift it to the right because it's at most. So it's going to be a 101.5. Sorry about that. So, and then 76 to 109, very similar to what we did above. 52. Should be able to calculate the normal and the standard, the normal and the standard distribution from the information here. So we have P is 0.05, N is 500, so Q would be 0.95. And we could test to see if N and Q, N times P would give us 25, and then the standard deviation would be the square root of N times P times Q, which would be 4.873. We have to make for the correction of continuity, so we subtract. In this case, we want to know, find the probability that 29 or more of the 500 calculators will be returned. So we're looking for 29 or more. So 29 or more. So we subtract it. So it's a little more confusing because at most we added because of the wording, but 29 or more, we're going to subtract it because this is going to be a lower bound. So 29.5. In this case, x is 28.5. Z would then be 28.5 minus 25 over 4.873, which would give us 0.72. Looking at the normal distribution curve, we have to be a little careful because we're wanting to know the area to the right of what Z gives us. So we're looking at 0.72. 0.72. It's going to be 1 minus that. So 1 minus 0.7642 would then give us the answer of 0.2358. And then 52C and 59DC is going to be the exact same approach. You want to be very careful again for what's going on for the probability here. 15 to 22. So you subtract 0.5 from the 15 and add the 0.5 to the 22. So this year you're going to look at 14.5 to 22.5. And then corresponding standard normal distribution for that. Very similar, 71 to 85, you're looking at 70.5 to 85.5. Corresponding Z values, and then find the area between. So hopefully this explains what's going on or explains how to correct for continuity, but once you've done that, it's the very same approach of what you've been doing in the previous chapter.